Hello viewers, welcome back to Coding Interface channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created a bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, linked lists, trees, graphs, and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can find the link in the description below this video. Let's jump into today's problem, Hamming distance. The Hamming distance between two integers is the number of positions at which the corresponding bits are different, right? So given two integers x and y, calculate the Hamming distance, right? So we are given with two integers, right? And the Hamming distance is nothing but the number of positions in which the corresponding bits are different, right? So let's go with an example that is shown here. So x is equal to 1 and y is equal to 4, right? So x is equal to 1 and x is equal to 1 and y is equal to 4, right? So by looking at this, you won't be able to tell the bits in which they are different, right? So what we essentially need to do is, so we need to convert this to binary representation and this also to binary representation, right? Before we could look. So what is the binary representation for 4? It's 1 0 0. So for x is equal to 1, the binary representation is actually 1. So but in order to make it is equal length, right, we need to prepend zeros, right? So this is what it is. So now what we are going to have is, we need to check the number of positions where corresponding bits are different, right? So here this one is 1, this one is 0, so that is 1, so that is one difference. So here second one is 0 0, that's not different, and this one 1 and 0, that is different. So totally the answer would be 2 for this, right? Basically the difference of the bits, wherever this is 0 is there and in that position it is 1 is there, and wherever 1 is there the position is 0 is there, right? So now that that is the Hamming distance definition, right? So how can we solve this problem, right? So if there are multiple ways to do it. So one thing is, yeah, just like what we did right now is convert x to its binary representation, convert y to its binary representation, and if there are any difference in the length, right, prepend with zeros, right? So let's say let me take an example of x is equal to 1 and y is equal to 10, right? So in that particular case, the lengths are, the x is equal to 1, so the length is just 1, and when y is equal to 10, the binary representation is 1 0 1 0 4, the length is 4, right? So now the first step is we convert the number into binary, so that's what we did, right? And then prepend the zeros. How many zeros we need to prepend? 3 zeros to make it equal length, right? So now that we made equal length, right, now compare the bits, right, where they are different. So this one, this is different, this is same, this is different, this is different, right? So the answer would be 3 in this particular case, right? So this is one approach. But do we really need to convert x and y into binary representation? That is a question. And if there is there a way that we can get away by not converting both these numbers, right? So yes, so what we are looking here is a number of positions at which the corresponding bits are different, right? So let's dive into some of the bitwise operators, right? So bitwise operation, bit manipulation techniques, right? So when can you get a 1 when the bits are different, right? Which operator can give you a 1 when the bits are different? So for AND, right, only the bits are 1 only if both bits are 1, right? So AND is not a possibility, right? OR, so when any of them or both of them is null, both of them is 1, it will give 1. So OR is also not possible. So how about XOR? So XOR is Yes, XOR is a possibility. When both bits are 0, it will give 0. When both bits are 1, it will give 0. But when one of them is 1 and another one is 0, that is when you get a 1, right? So now what we can use is, we can use an XOR operator, right? So X XOR Y, right? So this is the result that we get, some, let's say Z. So what we are going to do is, we are going to count the number of ones in Z. Okay, so now count number of ones in Z, right? Let's say XOR X XOR Y is Z. Now what we are going to do is count the number of ones in Z, which is the answer, right? Which is what we want. Because if you look at the XOR truth table, right? So XOR truth table, 0 0 will be 0, right? So let me take this and put several things, right? So 1 1. So when both are 0, it will be 0. When this is 0 and 1, it will give you 1. When 1 and 0, 1. 0 and 0 is 0. So this is XOR truth table. So that means when the bits are different, it is going to give us ones. When bits are same, it is going to give us zeros. That's the reason why once you do XOR, if you just count the number of ones, that gives you the answer that you want. All you are good looking is position in which corresponding bits are different. So first we will do XOR Y and we get a result, and in that result we get the count of ones. So this is the approach that we are going to look at in the code, right? So we looked at two different approaches. Approach one is this one, where we were converting all the numbers. I mean, basically there are two numbers, right, to binary representation, and then going through each bit, right, assuming the lengths are same. But if the lengths are not same, we have to prepend that many number of zeros. For example, in this case 1 and 10, we have to prepend 3 zeros, right? That's what we have to do. But instead of doing all that work, if we just do X XOR Y and get a result Z and count the number of ones in the approach 2 that we have talked, that will be a better approach over approach 1, right? So the code which we are going to look at is approach number 2. Okay, let's go ahead and look at it. So now, so simply I am doing a X XOR Y. I am calling it as an answer, and then I have a private method here to count the number of ones in the answer, right? So this get number of ones is going to take this parameter, and then it's going to count the number of ones while x is greater than 0, right? It's going to check whether x percentile 2, basically x mod 2 is equal to 1. If so, it counts, otherwise it doesn't. This is basically generating the binary number out of x, right? So but only we are counting when the percentile 2 is equal to 1, right? So that's how we are able to get the number of ones. So what is the time and space complexity for this? And space. So time complexity, let's say, yeah, so this is x XOR y, right? We could say, okay, since both are integer, it would take a constant amount of time, right? Since both are integers, right? Integer x and integer y. And then to get number of ones, right? So since this is also an integer, this while loop will be executing at most 32 times, because the integer is a 32-bit integer. So that means get ones will run for order of 32, right? Or you can say just 32 times, right? So overall what we can say is the time complexity is order of 32, which is nothing but a constant, we would say, right? If you want to talk in terms of the bits, right, order of number of bits in the given number, you can say. But since these are integers that we are dealing with, it will be order of 32. So in big O notation, order of 32, order of 20, order of 1, order of 2, they're all same. So that's why we are going to say the time complexity is constant. And what is the space complexity? Space complexity is, are we really using any space here? Yeah, we are using an answer variable and we are using a count variable, right? But so since these are like couple of variables, they're not much of space. So we will say space complexity is also order of 1. So time complexity is order of 1 and also space complexity is also order of 1, right? So if you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. I have posted this code to the GitHub repository. You can get the link from the description below this video. If you haven't subscribed to the channel, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.